Hello, everyone. Welcome back. I hope everyone's having a great time so far today. It's my pleasure to introduce our next session titled AI at the Edge, How Cloud Everywhere Works for Retail, coming from Karen Rhodes, Account Chief Technologist at Hewlett Packard Enterprise. Karen Rhodes specializes in providing emerging technology guidance to business leaders at global retailers. She has spent over 25 years in IT and worked in internet hosting, legal, and startup organizations prior to joining HPE in 2010. Please join me in welcoming Karen to the stage.
Hello, this is Karen Rhodes. I'm an Account Chief Technologist here with Hewlett Packard Enterprise, and I'm going to be talking about the AI at the edge and what HPE is doing. So we have a concept that we call cloud everywhere, and it's exactly what it sounds like. The cloud is everywhere. And whenever we are working with our customers, I wanted to give you guys some examples of what we mean by cloud everywhere. So here are some extreme examples. We literally do cloud in space. So if we look at the left-hand option here, this is actually Spaceborne Computer 2. This is our second version of a supercomputer on the International Space Station. And we learned a lot of things in our first revision. Things like don't put the power button where buttons can be pressed. Things in space do fly by, they end up hitting the power button. That's not a good thing. But cloud everywhere means that there are some workloads that run on these supercomputers in the International Space Station, but this also connects to the Microsoft Azure cloud. And there are other workloads that are better serviced in Azure than they are on these supercomputers. That is cloud everywhere. Use the workload where it resides. Another example of cloud everywhere is our F1 race car work. So HPE works with F1 race cars. There are hundreds of sensors on these race cars, and they are creating terabytes of data. There are essentially two different users that are accessing this data. First, you have the driver themselves. And that driver needs to be able to, at a glance, see what is going on with the car. How are the tires reacting? What is going on with the road conditions on that day at that very moment? Then there is a set of data that goes back to supercomputers. And those computers analyze the entire race. Now, when we started doing this, they were averaging 1/10 of a second faster per race. Now, me and you as humans, we look at 1/10 of a second as you can't even really determine that without having a stopwatch in front of us. But F1 race cars, that's the difference between winning and losing a race. Now, aggregate over the first year of race cars, using this analytics platform, they ended up shaving 2 full seconds off of the race times. So now F1 race cars pretty much universally use an AI algorithm to help them optimize their performance race after race. The third example of cloud everywhere, and this is really an edge use case of these smart cities. And I look at this as the closest to retail. And I look at smart retail and smart cities as very similar. You have all of these IoT devices at the edge, just like a smart city. And smart cities have everything from air quality detection, sound sensors to detect things like gunshots in a city. They have pothole detection. They have detectors on the garbage cans to determine which garbage cans need to be picked up on certain days and which ones can actually wait a few days. That saves cities millions of dollars in actual trash collection. There's also video analytics that goes on at smart cities, things like abandoned packages. And all of that information comes back to a centralized dashboard that you see here, where people who are non-technical are able to interpret the sensor data and make those instantaneous decisions of, I need to dispatch the police or the sanitation teams in the city out to those specific locations. But it's not just sensor data. It's also your citizen sentiment analysis. So this is information from Twitter and Facebook, all your different social media feeds come into this dashboard as well and give you an insight into how is your city operating? How are your citizens feeling about your city? And this is where I look at retail. We are always looking at making our customers absolutely happy whenever they come into our stores. We need to get that sentiment analysis. Yes, we have IoT sensors that are in our stores giving us some great feedback, but the best feedback of all is still going to be that human feedback. So how does HPE do cloud everywhere? If we look at the right-hand side of this screen, we see kind of our traditional AI environment. We've got a core, and that core could be a data center or a co-location facility. It could be a cloud provider. Really irrelevant. It's the core. And we're doing things like CI/CD pipelines. We've got MLOps running in there. We've got a data lake. We've got a GPU cluster. Great. We're doing our normal analytics stuff there. Where HPE differs is that we found it very problematic whenever retailers at what we call the near edge were having to send all of their data from the retail store back to the core before they could make their insights and determine what needed to happen for that particular region of the country or maybe for their entire fleet of stores. So what we did is we created a data fabric. And this is the Emerald Data Fabric. And what it essentially does is allows you to have a data lake in your data center and then a data pond at your retail store. And these are unified. You've got data orchestration, everything is in there. And it is one namespace. This is very important to understand in that your data lake that's in your core now has access to all of the information at your retail sites without you having to port that information across very slow WAN links back to your core. Okay, so single namespace. Now your data analysts can start doing your research in the middle of the day. They don't have to wait for a data dump and then cleansing to happen in the middle of the night and then run the report the next day. You can make insights instantaneously. So that is a very important differentiator that HPE has brought to the market for people like retail. Now, when we also look at the near edge, we call it the near edge because we understand that not every retailer is the same. If you're a large retailer, this may be a store cluster of maybe 3 servers that have storage inside of the servers, and you're a large retailer, that's great. But maybe you're a small retailer and you don't have space for servers in your store. That near edge could be in a telco POP. It could be something that is near a whole set of your stores. And then we have a concept called the far edge. And this is a new concept for some retailers and not a new concept for other retailers. These are things like Jetson devices. So if I look at a retail store that has older cameras, I have the option of either upgrading all of my cameras to a higher resolution camera, or I could use machine learning to actually denoise a very staticky image from a camera and give me a high resolution camera image from a low resolution original image. And that's something that is using machine learning at that far edge. We run into some issues on how do I manage that machine learning model though. So essentially what HPE is advocating for people to do is analyze your data in place, whether it's the micro edge if you're using them, whether it's in your store, whether it is in your core. Use the data in place. We're also advocating that you delete your data after you gain insights. So just like you don't keep all of the receipts from your shopping, you keep a tally of what your spending was for the month. Just like you don't keep every receipt, over time, you keep 7 years of tax records and then you start removing those from your own household. We recommend that you do the same type of a thing with your data environment. And yes, you need data to train your models, but you need clean data, relevant data. You don't need data that is 10 years old. So as you're ingesting data, you should actually have a process of deleting data at almost the same speed as you're ingesting it. And next, we're going to talk about training the models at the edge. Once again, we're trying to do everything as close to that data as possible. So HPE has a platform that allows us to train our images at the edge. So normally people would get their data, they would put it back to the core would do the training, the machine learning model would be updated and it would push that down to the edge, and then you would do your inferencing at the edge, and then you would update everything back to the core, do your training again, and it would just be this vicious cycle of constantly moving data over expensive links, paying egress fees, ingress fees, whatever it happened to be. Now, in this environment, this diagram, the edge could be a store, and the cloud in the middle could be your core, whether it's a cloud, data center, colo, what have you. If we're looking at the micro edge devices, such as a Jetson device, these could actually be an example of one store. with lots of micro edge devices, and the cloud in the middle could represent a simple like 3-server cluster. Whatever it happens to be, we are advocating that you use a federated learning model. And what this federated learning model does is it allows you to keep the information on that edge device, whether it's a Jetson device or whether it is a store cluster. Keep the information where it exists. Now you're going to have things like model drift, you're going to have outliers, you're going to have telemetry information. That is a very select amount of data. It's not the entire data set, very select amount of data. That is what goes from your edge back to the center. Then your machine learning algorithm looks at those outliers, your model drift, creates a new ML model, and goes ahead and pushes it back out to the edge. Now, what we're seeing with ML is that most of the retailers have geographic areas. Maybe it's, for example, Texas is a geographic area for you. That ML model needs to be trained for that particular geographic area. Boundary box whatever you want to for your customer base. And it may be, this city in this town and another city on another coast may actually need to be working together because they have such similarities in your customer base. That's fine, but keep the data in place and get your insights there. So what we're talking about here is doing management of your edge devices, your applications, your data management, your ML ops, creating that data lake that you've already got, and just creating data ponds as extensions. Once again, one namespace. So everything looks the same. Just like whenever you bring up a browser in your computer, you're going to see all the files right there. Same concept, but you're actually seeing data in all of the different stores. You select which stores you want your model trained on. Great. Don't train the other ones. So low latency, we're removing a lot of the data that you're having to port either from those edge devices back into your distribution, telco pop, whatever it happens to be, or from your stores back to your core. So real-time insights are able to be done by your analysts that are at the core. They're able to see information going on in real time at a store. Hey, we're having a rush on everybody's buying barbecue grills. Why are they buying barbecue grills? Wow, wait a minute. Our barbecue grills somehow got priced as $5. That's a problem, and you need instant insight on things like that, where your automatic pricing model has gone awry, and you need to make that change in real time. You cannot wait for that data to come from the retail store back to your core to make a change. You have lost your profitability by allowing that pricing problem to proliferate through an entire day and possibly through multiple stores. So what we're talking about here is federated and swarm learning. Okay, these are all things that we've been doing for quite some time, so we are glad to help you with it. Now, when we talk about AI, I highly advocate that you look at how do you make money. Every retailer is different. Why you exist as a retailer needs to drive what AI programs you do, and be selective. Now, the people in retail that are merchants or buyers, I like to call them data analysts, they've been doing AI for decades, whether it was literally reams of data in paper, spreadsheets that had pivot tables that were absolutely insane, SQL databases. These people have been doing this for a long time. This is a very natural evolution for them. And they're doing, product substitutions and, basket odd ratios. That's native to them. What we're seeing is additional people in your environment that's starting to use AI models. Your real estate may realize that there's only 10 users or 10 customers at a store, making it profitable. Well, maybe you need to do concierge service for those 10 customers, reduce your footprint of your store, and sublease the rest of that space to an online retailer who has similar customer base to you. That allows you to increase your internal rate of return on your real estate. That is all AI, right? That's that customer insight you're getting. Marketing has been great at our social media, loyalty programs, things like that. But now retailers are realizing that they can start marketing the products that are on their shelf on behalf of their suppliers. That's an entirely new revenue stream. So real estate has a new revenue stream, marketing has a new real estate stream, and your associates need to be a key part of your AI. So Yes, we have theft prevention, and those are lovely solutions. But we also need to look at the associate as they are the subject matter expert that are the closest to your customers. If they look and give you feedback, just like we talked about in the smart cities where somebody tweeted and said, hey, this is not good, you need to listen to your associates and listen to your customers. Don't just look at the algorithms. If your social media feed or your associates don't have a direct feed into your merchants, your real estate, your marketing, you're going to have a gap. And you need to make sure that that human element is brought in to all of your analytics and AI environments. So HPE is here to help. We have been doing this for quite some time, obviously, and we want to be of service to help you be the best retailer that you can be. So please reach out to us, aisales@hpe.com. I hope you have a wonderful day. Thank you for giving me the gift of your time.
Wow, what a great session. Thank you. I hope you all enjoyed it. Please make your way to your next session. Also, don't forget to check out the networking, accept your connection request, and explore the AI exhibits. Have a great time.